In this video, we are developing Basels interpolation formula. So, what is the drawback in Gauss forward, Gauss backward, and Stirling's formula? You can see here. In Gauss forward formula, Gauss backward, and Gauss and this Basels formula, actually, we are having only one central point. But the desired value may be somewhere, for example, in between 0 and 1, or in between 0 and -1, because this is the center. This is nearby the desired value. So the difference between the desired value and the origin point may be larger. So here point may be, for example, say here, or point may be here. So this, if somehow we are able to take two origin points, that means range of origins, range of, rather than single point we are taking the range, then this will be more beneficial. So that's why we are having Basels point here. Rather than single origin point, we are having two origin points. That may be, for example, say 0 and 1. Generally we are taking 0 and 1 as the origin point. So if you take two origin points, then this will be more beneficial. Fine. So here we are taking this approach. So how to apply this approach? For example, in this column, if I am using same table, and suppose we are using two origin points, so this and this, then the path will be 2, and then they will move to the single, double, single, double, then single, then double, then single, and then double, like that. So this will be the path: double, single, double, single, double, single, double, single. This is black part is your Stirling's formula. Basels formula. This will be the Basels formula. Fine. Stirling's is the average of these two, which we have already developed. This is the Stirling's formula. So now here, so this is the Gauss forward formula. This is the Gauss backward formula. Now here origin is 0. So now we will shift the origin, because we need origin as 1 for backward formula. This is 0. This is for Gauss forward. This one will be the Gauss backward. So how to shift the origin? So to shift, here origin is 0 regarding this. So now to shift the origin at 1, replace u by u minus 1 and adding each argument by 1. These are the arguments: 0, -1, -1. These are the arguments. So they are added, they are shifted by 1. So the formula in question number 2 becomes f of u, because after substituting all these, again you are getting a function of u. That's why we are not writing here u minus 1. We are just replacing f of u as it is, because function is of u will be final output. So f of this argument is shifted by 1, so f1. U is replaced by u minus 1. Delta f of -1 and adding by 1, so f0. So u is replaced by u minus 1. So this will be u equal to u minus 1. Here shifted by 1, so 0, and so on. So this is the, and now take the average of equation number 1 and equation number 3 as usual, term by term average. So we get this result. This is our Basels formula. Fine. And the approach is shown here graphically. This is the approach. This is the approach. Here we are writing central differences also. In place of forward, we are also writing the central differences. And this is delta average of these two, -3, -2, delta f of -5/2. Average of these two is, this value is equal to delta f of -3/2, because this is the average of these two. Similarly, the average of these two is -half. So delta f of -half, and so on. Similarly here, we are, if we are taking the average of these two, -3, -2, fine, this, sorry, this is the average, -5/2, -3/2. Take the average of these two, so delta f of -2. Take the average of these two central differences, this is nothing but delta 2 f of -1, and so on. So this is the table. Now example. So here we have this data Find the value of function at 27.4 with the help of Basels and Stirling's formula. 27.4 is nearby center, that's why we are applying the central formula. So here first we are applying the Stirling's formula. So we have constructed this table and we have assumed center as 27. 27 is because 27 is nearby 27.4. So that's why u is 0, then u is -1, -2, 1, 2, 3. So this is our u. So x naught is 27, x is 27.4, h is 1, and that's why u is equals to x minus x naught by h. Now we have applied the formula. This is the formula, Stirling's formula, average of Gauss forward and Gauss backward. Substituted the values of different terms, and finally we get this result 3.6497. Fine. Now here Basels formula. In Basels we are having two origin points. So two origin points. So rather than 27, origins are 27 as well as 28. Then double, single, double, single, double, single. This will be our path, so that we can cover up all the columns. And then this is the formula. This is the formula. This is the formula. Basels formula. Substituted the values in this formula and finally we get the result. We get the result. Fine. Now you can take this as your, this question or this problem you can take as the assignment. This is the table and thus apply the formula. Fine. So you can see and you can note down this. Fine. So now in the next class we will discuss the interpolation by unevenly spaced data points. That means we will discuss Lagrange's interpolation formula and Newton's divided difference formula. Fine. Thank you.